Alright, so we got this question over here, question 6. We have f of x is equal to 2 times 3 to the x, and x can go from minus 2 to 5. Now, this is telling me what? This is giving me what? What's the name that we get given for that? That's telling us our... That's the domain, huh? That's from where to where on the x. Now, we've got to find out from where to where on the y. Now, to do that, basically, we just put in our extremities of our x into this equation, and it will give us our from where to where on the y. So all I do is I substitute into this. I find f of minus 2, and that will give me my starting point. So it's going to be 2 times 3 to the minus 2. And I find my f of 5. And that will give me 2. That will give me 2 times 3 to the 5. Now, it would be, if you want, and it's probably quite a good idea to actually just draw up this graph. So you actually, when you draw it up, you see that you've got a graph something like this. It's an exponential graph, and it'll actually go through 2 if you draw it up. And we're actually looking at from minus 2 to 5. So when we find this, we're going to find that value, and we're going to find that value. So we can see that this value and this value will give us our range from where to where, on the y-axis. So what is this equal to over here? What's 2 times 3 to the power of minus 2? All right, so it's going to be 2 to the 2 over 9, isn't it? Because 3 to the minus 2 is 1 over 3 squared. 1 over 3 squared is a ninth. So and that equals to be about 0.222. So it goes from, and this over here will be a positive 29. 3 to the 5 is going to be 243 is squared. Yeah, 243. So it's going to be 486. Yeah, 486. So your range, therefore, will be your y is going to be greater than equal to 2 over 9 and less than or equal to 486. The reason why we say the equal to also here is because we were told here it's equal to. You see, it's greater or equal to. So we actually equal to that point. So we've got those two values there. All right, and then find the value for x that gives you this. Now that worked out to be quite easy to do, because you just put 162 is equal to 2 times 3 to the 3 to the x, like that. When I divide both sides by, there were quite a few of you that multiplied this 2 times the 3 and said 6. You can't do that, all right? This is 3 to the x. You've always got to do this separately. So you divide the 162 divided by 2, that by 2, that cancels, and that becomes 81. 3 to the 4 is equal to 81, so that's 3 to the x. Therefore, x is equal to 4. Yeah. All right, and then going on to the last one here. Right, the diagram below shows a graph of a quadratic function. The graph passes through the points 6, 0, p, and 0, and the maximum point has the coordinates of 0.5, this one over here, 0.5, and 30.25. It says calculate the value of p. Now, this 0.5, because this is the maximum point over here, is actually the value of the axis of symmetry. All right. This over here, the halfway point, if we went down through there, would be 0.5. So this point and this point, this value here from there to there would equal that amount from there to there. Okay? So this goes from 0.5 to 6. So this is 5.5. And therefore, this amount, it starts at 0.5. So that's 0.5. And then it will go further 5. So this is actually minus 5 there. Did you follow that? Did you? You sure? Because a lot of you said negative 6 here. Good. All right, so we got that. And then we've got that, so we've got those points. And then it says, given that the quadratic function has the equation of this, where b, c are integers, find b and c. So what we're going to have to do is we're going to have to substitute these points in to this and find out what they are. So we're going to have, I would take perhaps this point over here, and we could use also I think I would probably also use my axis of symmetry. We just need two equations. So I would use axis of symmetry is going to be pretty easy to find b, because x is equal to minus b over 2a. When I look at this graph over here, what is my a in this graph? A equals, not 1, close, negative 1. Here, the a is always a number in front of the x squared, so it's negative 1. So if I put it in here, my axis of symmetry, I'm going to have my axis of symmetry is 0.5 is equal to minus b over, this is 2 times negative 1. So b, I'm going to multiply both. If I'm 2 times negative 1 is negative 2, when I multiply that, I'm going to get negative 1 is equal to negative b. Therefore, b is equal to 1. Okay? Does that make sense? Right? B is equal to 1. And then, once I've got that, then the rest of it is pretty straightforward, because I can use this point over here to put into this equation to get another equation. So I get y0 is equal to minus x squared. Now I already know my b is 1, so it's plus x, alright, plus c. And I put in my x is 6, so I'm going to get 0 is equal to minus 6 squared plus 6 plus c. Here I'm going to get we're going to get here, so this is going to be 6 squared is 36, it's going to be minus 36 plus 6 is equal to plus c. So this becomes negative 30. Take it over to the side, it becomes plus 30 is equal to c. So we've got b then is equal to 1 and c is equal to 30. Like that. Why did I use the 6? Because you see, when I'm wanting to get two equations, I must use points on my graph. So I use this point over here, 6 and 0. So this is my y is 0 and my x is 6. You could have used this one over here also, if you wanted to. You could have also used that one if you wanted to. But they all seem much more complicated. I went for my simplest way. So I use this because I've got my axis symmetry, and I knew that my a was equal to negative 1. I knew that was going to make this really simple. All right? And then I chose my next simplest set of numbers that I thought 6 and 0. But you could have, there was a number of different ways you could have done it. Okie dokie. So That is it.